And now we discuss the ASK modulator, and we say that ASK modulator is simply generated by applying the input digital sequence or the input binary data sequence, and it is multiplied by the sinusoidal carrier. And both of them, or the two inputs, are combined by what is called a balance modulator, which is also the same as the product modulator. And a simple diagram is shown in this figure, in figure 9.4, whereby we have a unipolar non-return to zero encoded binary stream, the one that we have said it is producing the rectangular pulses, and we have the carrier signal that is sinusoidally generated, and therefore when you multiply the two signals, they are going to generate for you an ASK signal. An ASK signal is the one that we have also called on-off keying. That means that at some point we are going to be having a signal that is of the frequency of the carrier, and then at another point we are going to be having zero amplitude or zero frequency, simply because at that point a binary zero is being transmitted. So we clearly see that the output of our product modulator, which is a balance modulator, is the product of the input signal or the binary signal and the carrier signal. And we have actually done that expression where we are able to see the amplitude of the carrier varies with the amplitude of the input binary sequence. And we have seen that VB is the binary input data, and the binary input data may be a 1 or a 0. Therefore, when it is a 0, there is no amplitude that is transmitted, whereas when it is a 1, then we are going to be transmitting the full carrier amplitude. VC is the one that we have defined. Sometimes we are using different signals, but simply we are using different notations, but this VC is one that I have illustrated to be equivalent to root of 2 over TB, and this value is conveniently chosen. So you might find different texts are using different values. The output is passed through a bandpass filter. So this output, the one that you are receiving, is going to be passed through a bandpass filter, and that bandpass filter is generally used to remove high frequency components. What you remember is that when you multiply cos A that is coming from the carrier, now I think that is not exactly the concept. The idea here is that the objective of bandpass filter is simply to contain the frequency spectrum of the ASK signal. Sometimes the product is likely the input binary data stream has having very high frequency component that requires to be cut off, so that what is left is only within the frequency of the carrier, and therefore that is the purpose of the bandpass filter.